So that's what we're going to be working on right now. So here goes some probability. So I tell you probability of m is equal to 0.8. Probability of n is equal to 0.25. Probability of r is equal to 0.6. So part A said if the probability of m and n is equal to 0.20, are the events m and n independent? So right now we want to test to see if the events m and n are independent from each other. So that means we're going to be using these two probabilities. Okay, we want to test that m and n are independent from each other. So we want to see if the probability of m and n is equal to the probability of m multiplied by the probability of n. So far, any question on how I got that formula? All right. So if you look at the probability of m and n, they already gave us that probability. They told us that probability is going to be 0.20. So we're going to say this is 0.20. Now what we want to do, we want to get the probability of m. Probability of m, they tell us that's 0.8. Then what we want to do, we want to get the probability of n. Probability of n is 0.25. So what we want to go ahead and do, we want to go ahead and multiply these two out. So if you have a calculator or your cell phone, just do 0.8 multiplied by 0.25. If you multiply those out, what do we get?
0.2.
Yeah, 0.2. So you get 0.2 or 0.20. So the left side and the left side and the right side are equal to each other. So since the left side and the right side are equal to each other, we're gonna say the events of m and n are independent. And that's it for A. Any question in regard to A? All right, let's do B. So for B, if you look at it, it says if the probability of P of n and r is equal to 0.3, are the event n and r independent? Right. So now what we want to do, we want to test to see the event n and r, are these independent? So now what we're going to be doing, we're going to use the probability of n, and we're going to be using probability of r, because those are the two events we're testing to see if they're independent now. So we're going to say probability of n and r is equal to the probability of n multiplied by the probability of r. Any questions so far on why I put probability of n and r is equal to probability of n multiplied by the probability of r? All right, great. So if you look at the probability of n and r, they tell us it's equal to 0.3. So we're going to replace this with 0.3. If you look at the probability of n, they tell us that's 0.25. They put 0.25 there. If you look at the probability of r, they tell us that's 0.6. So we're gonna do 0.25 times 0.6. So what's 0.25 times 0.6?
0.15.
Cool, thank you. They get 0.15. So if you look at 0.30, it's not equal to 0.15, so we're gonna put not equal to. So since they're not equal to, we're gonna say the events in and are dependent on each other. And that'll be it in regard to B. So since the left side is not equal to the right side, we're going to say the events are not independent. They're actually dependent on each other. Okay, if they're independent from each other, both of the probabilities should be the same. Since they're different, we're going to say they're dependent.
So when they're independent, the answers are basically the same, and when they're dependent, they're not. They don't equal this.
Correct.
Oh, okay.
Yeah. So when they're independent, the left side and the right side will equal to each other. If they're dependent, the left side and the right side are not equal to each other. Right. So let's do one more, and then we'll do Bain's rule. All right. So this one we're going to use a two-way table. So from the two-way table, we're going to get all the information. So for this two-way table, the two-way table is giving us a gender, so telling us if they're female or male. And then giving us the information whether they like Game of Thrones or they don't like Game of Thrones or don't watch Game of Thrones. So what we want to do here, if you look at it says, are the events being female and liking Game of Thrones independent from each other? So those are the two events we want to see if they're independent from each other, whether they're female or liking Game of Thrones. So if they're independent, that means it doesn't matter if they're female or male, whether they'll like Game of Thrones. If they're dependent, it means like it does depend on the gender. So that's what we're trying to figure out. So for female, you have to make this a little bit easier. I'm going to put F for female. And for liking, sorry about that. For liking Game of Thrones, we're going to put L. So I'm going to just go ahead and use the formula for independent or to check to see if they're independent. So to check to see if they're independent, we're going to find the probability that they're female and like Game of Thrones. And that should equal to the probability of them being female multiplied by the probability of them being, well, of them liking Game of Thrones. Everybody good so far with the formula? All right. So for being female and liking Game of Thrones, so for this one, kind of the easiest thing to do is to do this. So first you want to find the female. So females are here. For liking Game of Thrones is all of these people over here. So we want to find female who like Game of Thrones. So we want to find female who like Game of Thrones. So the easiest way to figure out how many female we have that like Game of Thrones, if you look at the two, well, the row and the column that I highlighted, pretty much the people that get overlap are the people who are female and like Game of Thrones. So if you see who did I overlap, I actually overlap this square over here. So I actually overlap this square right here. So this 60 represents female who like Game of Thrones. So for here, I'm gonna put 60. And then we're gonna divide this by 123. Any question on where does the 60 divided by 123 come from? All right. So up next, what we're going to do, we're going to find the probability of being a female. So how many total female do we have in this two-way table?
$90.
Yeah, 90. So if you look right here, it says 90. So you put 90. Good job. So you put 90, you divide this by 120. You always divide it by the total. How many total people do we have that like Game of Thrones? So how many?
82.
Yeah, 82. Perfect. And you divide this by 123. All right. Everybody got how we got 90 divided by 123 times 82 divided by 123.
Yes.
All right. So what I'm going to go ahead and do, let me actually go ahead and get class calc. All right, so let me share class calc. All right, so on class calc, I'm first going to do 60 divided by 123. So I'm going to put division. So we'll do 60 divided by 123. Oops, too many twos. 123. So we're going to get 0.4878. Any questions so far? I got 0.4878. All right, so let's do the second one. So the second one we'll do division. So we'll say 90 divided by 123. But remember, we have to multiply this. And we have to do 82 divided by 123. And if you look at that, we get the right side equal to 0.4878. So if you look at the probability we got for the left side is equal to the probability of the right side. So that means we could say the events of being female is independent of
Mr. Where do you press on to do the times 82 over 123 next to it?
Oh, you press this one right here. You're talking about the multiplication?
No, I'm trying to get like the fraction next to.
Oh, you press this one again. So here, I'll do it again. So you say 90, and then you put division, put 123. So then what you want to do, you press this button, you have to make it go up front, and then you press multiplication. Then you do 82, And then you say divide it by 123.
Okay,
Does that
thank you.
help?
Yeah.
Cool. All right. So let me switch it over to my screen for that way you can see what I just wrote on my screen. And that way we could be done with this portion. So we'll put the event of being female is independent of the event of liking Game of Thrones. So both of them are independent from each other. If one of them if the left side wouldn't have equal to the right side, then you put their dependent. But since they're both equal to the same value, we put their independent from each other. Yeah. So let's go on to this next one. All right. So this is the Baynes rule. So the Baynes rule is a conditional probability, or how to find a conditional probability. But in this case scenario, we're not going to be given all of the information. So some of the information will be missing. So what we have to do, we kind of have to figure out how to get the probability with the given information that's given to us. And that's where this formula could come into play. So if you look at it, we have probability of A, and then we're going to multiply this by the probability of B, given A has already occurred. And then we're going to divide that by the probability of A times the probability of B given A. So pretty much, if you look at this, and if you look at this, they're exactly the same thing. All right, give me a minute, because I think it stopped sharing. So share the whiteboard. So if you look at the top portion, that bottom portion is exactly the same. So whatever you put on the top, you put on the bottom. And then what you're going to do, you're going to add it. So I don't think you can see it, but this one right here, it says probability of A, but it has a little bar on top of it. So what that mean, in order to find that, you have to get the probability of that is equal to 1 minus probability of A. So pretty much it's the complement. So whenever you see that bar on top, it just means that you're finding the complement of that event. So for that one, you're saying pretty much probability of not A. And then right here, you're going to find the condition, the probability of B, given, once again, it's not A. So for this one, we're going to be using the Baynes theorem. So that's the formula we're going to be using. So I'm going to show you two different ways how to do it. So the first way I'm going to do it with the formula. The second way I'm going to do it with a tree diagram. And then essentially you can just pick whatever one you want to use. So it doesn't really matter which one you choose, because both of them should give you the same answer. All right, so let's go ahead and just look at this problem. So for this problem, it says a certain virus infects 1 in every 400 people. A test used to detect the virus in a person is positive 85% of the time if the person has the virus, and 5% of the time if the person does not have the virus. This 5% result is called a false positive. Let B be the event the person has the virus, and P be the event the person tests positive. Okay, so for this one, we're gonna be doing two. So it's V is gonna be they have the virus. P is gonna be the test positive. So right now, what we're gonna go ahead and do, we're gonna go ahead and look at all of the probability they're giving us, and we're gonna put labels into them. So we're gonna just label them. So let's look at this one right here. So it says a certain virus infects 1 in every 400 people. So they're giving us the probability somebody has the virus. So what's the probability somebody has the virus if it affects 1 out of every 400 people?
Do we do 1 over 400?
Yeah, perfect. 1 out of 400. Great job. They do 1 out of 400. Perfect. All right. So let's go ahead and now let's look at the next thing. So here, let's do a different highlight. So it says a test used to detect the virus in a person is positive 85% of the time if the person has the virus. So this one's telling you if the person has the virus, it's positive 85% of the time. So in this case scenario, what do I already know? Do I already know they tested positive, or do I already know they have the virus? If you want, you can put in the chat on whether they have the virus or not. So what do we already know? Do we already know they have the virus, or do we know that they tested positive? Well, if you look right here, it says if the person has the virus. So it's telling us we already know this person has the virus. So the way we'll write this, we'll say probability they test positive given they have the virus. And that will be equal to 0.85. Right. So the last probability that we have is the 5%. So it says 5% of the time if the person does not have the virus. So it's telling us they test positive 5% of the time if the person does not have the virus. So we'll say probability someone would test positive given that they don't have the virus. So to signify that they don't have the virus, where you're gonna put a bar right here. All right, so that's all the information that they gave us. Any question in regard to the information that's given to us? All right. So let's do part A. So for part A, it says find the probability that a person has the virus given that they have tested positive, i.e. find probability of V given P. So we're gonna find probability of V given P. All right, so let's go ahead and look back at the formula. So if you look at the formula, it says probability of A given B is equal to probability of A. So whatever on the first, that's what we're going to put on top. So we're going to put probability of V, And then if you look at it, it says B given A. So that's going to be probably a P given B. So that's what we put on top. Any questions so far on how I got the top portion? All right, so let's do the bottom portion. So if you remember, I told you that these two are exactly the same. So I'm going to put this again. The probability of V times probability of P given B. Now let's add it. So if you look right here, this is probability of A, but it has a bar up here. So we have to get the B, the probability of B, but we put a bar over it. And what you want to do, you're going to want to multiply that by probability of B given A. So we'll say probability of positive test results given they don't have the virus. So that's how you want to use the formula to get this answer. Any questions so far on how I put the pretty much the notation for the formula? All right, so all we're gonna go ahead and do is substitute stuff in. So say like probability of V, there's this one over here. So you put 1 out of 400. There you go, 1 over 400. And then if you look at this one, that's this over here. So we multiply that by 0.85. Then what you want to go ahead and do is divide this. So remember, this portion and this portion is exactly the same. So you do 1 out of 400 times 0.85 times 0.85. So up next, what we gotta go ahead and do, actually, we kind of have to find what this is. Okay, if you look at it, so if you look at it, it says probability of V bar. So that means we have to find the complement of it. So we know the probability of V is equal to 1 out of 400. So if I want to find the probability of V bar, what would that be? Or how would I go about finding that? Well, if you kind of think about V bar is the probability that they don't have the virus. So if I know 1 out of 400 people have the virus, how many people don't have the virus out of those 400 people? Well, if you kind of think about it, if 1 out of 400 have the virus, then that means 399 out of the 400 don't have the virus. So I will put 399. Cool. Thanks, Alexis. All right. So we'll put right here plus 399 out of 400 multiply by this, which is 0.05. And that's how you do it with the formula. So now what I'm going to go ahead and do, there's no question about any of these values that I got here. I'm going to enter this into ClassCalc. Any question on how I got this? All right, so let's go ahead and use ClassCalc. All right, so what I'm going to do, I'm going to start off with a fraction. So that way I know this is my top fraction, this is my bottom fraction. So if you remember for this one, you do 1 divided by 400. Then what you want to do, you want to hit the arrow to make it go up front, and then you say multiply by 0.85. Now what I want to do, I want to go down here. So we're going to say 1 divided by 400. You put this arrow to make it go up front, and you say multiply by 0.85. Then what you want to do, you want to press the add button. You press 399 divided by 400. You press the arrow button and you multiply it by 0.05. And that's your answer. So if you look at it, give me 0.0409. So we'll say 0.0409. All right. And that's how you do the Bangs rule. Any question for that first problem? All right. So what I'm actually gonna do, I'm not gonna do B. I'm gonna do A again, but for A, I'm gonna do it using the tree diagram. So that way you can see like how you get the same answer using the tree diagram or using the formula. So I'm sure my iPad again. So we're gonna go ahead and do, we're gonna go ahead and find this probability again. But what we're actually gonna go ahead and do, we're gonna just go back to the O formula for conditional probability. So if you remember the O formula for conditional probability, it is the probability of V and P, all divided by the probability you get a positive test result. All right, so let's go ahead and do a tree diagram. So for the tree diagram, it gonna look like a tree. So for the tree diagram, you're gonna just put out all of the different outcomes that are possible. So if you kind of think about it, for the tree diagram, so you first have to put like how many people could get the virus and how many people can't get the virus. So we're gonna put people who have the virus and people who don't have the virus. So of the 400 people, how many people did we say have the virus?
1.
Yeah, 1. So we'll put 1 out of 400 here. So I know 1 out of 400 people don't have the virus. Well, sorry, have the virus. So that means I know 399 out of 400 people don't have the virus. So you always start off with the virus. So then the next thing you want to go ahead and do, you're going to extend another branch. So this branch is going to represent what do you get on your test. So you can either test positive or you could test negative, which negative we're going to put a bar. So we could go, you could get a positive test result or you could get a negative test result. So if you have the virus, what percentage of the time is it going to test positive?
85%.
Yeah, 85%. Thank you. They put 85% right here. So one thing you have to know about the branches should always add up to 100%. So if this is 85% or 0.85, this value, when added to 0.85, should add up to 1 or 100%. So I go 0.85 plus 0.15, that add up to 1. So if the probability you test positive is 85%, the probability you test negative is 15%. They always have to add up to 1 or 100%. So let's go on to the next one. So now we're doing for people who don't have the virus. So what percentage of the time is somebody going to test positive if they don't have the virus? Well, if you remember on this one, we said it was 5%. They put 0.05. So if the probability you test positive, given that you don't have the virus, is 0.05, what should be the probability you test negative? So what should be this branch probability?
Is it 0.95?
Yeah, 0.95. All right. So that's our tree diagram. So using this tree diagram, we're going to be able to get all of the answer, well, the answer for this problem. So I'm going to label, so this is branch A, this is branch B, this is branch C, and this is branch D. So when I say branch A is this entire thing right here. When I say branch B is this and this. Branch C will be this and this. And then branch D will be all of this. So if you look right here, we want to find the probability somebody has the virus and tested positive. So which branch will give us that information? So we want them to have the virus and test positive. Here, we'll make it into a poll if you don't want to shout out the answer or put the answer. So all right, so far 5 people have voted. All right, we'll give you 15 more seconds. All right, so let's see what do we get. So share the result. All right, so if you look at the result, we got A. Cool. And A is correct. So we're going to just use A. So what we want to do, we're going to use, oops, not good. So we're going to use branch A. So in order to use branch A, so we're going to use branch A. So if you look at branch A, we have the probability you have the virus, and we have the probability that you test positive given you have the virus. So what you have to do for those, to get that probability you have the virus and tested positive, we have to multiply those two probabilities. So for the top, we'll you put probability that you have the virus, multiply by the probability you tested positive given you have the virus. All right, so that what goes on top, the probability of V and P. All right. Everybody good with that value on top? Okay. So now we're going to get this probability in the bottom. So for this probability in the bottom, we want the probability that they tested positive. So now what I want you to do, I want you to choose which of these branches give me a positive test result. So we'll do a poll again. We'll relaunch this, continue. So all I want you to do is tell me which branch will give me a positive test result. All right, so you got like 30 more seconds to vote. All right, so let's end it and let's share. All right. So if you look at it, what are the two answers that people most gave for this class?
A and C.
Yeah, good. A and C. So technically, A and C are your correct answer. So for this one, there were two values. Because remember, we want a positive test result. And if you look at branch A gave us a positive test result because this is positive. If you look at branch C, well, that one also gave us a positive test result, which is this one. So for a positive test result, there's actually two ways to get a positive test result. Because you could get a positive test result when you have the virus, but you can also get a positive test result when you don't have the virus. So that's why we're gonna use both of these both of these branches. So first you're gonna get the probability of this branch, which is just 1 out of 400 times 0.85 plus now we want to get this probability for this branch. So what we're gonna do, we're gonna get this and this one, and we're gonna multiply them. So you get 399 out of 400 multiply by 0.05. And if you look at this answer and what we got when we use the formula, we got exactly the same numbers. So you could either use the tree diagram, or if you want, you could use the formula. Both of them should give you the correct answer as long as you label everything correctly. But that's it for that problem. Any question for that last problem? Okay, so what we're gonna do one more for this one. Here, we'll do something not involving death. Here, let's do this problem. So for this one, it says, in a factory, there are two machines manufacturing both. The first machine manufactures 75% of the both, and the second machine manufactures the remaining 25%. From the first machine, 5% of the both are defective, and from the second machine, 8% of the both are defective. A bolt is selected at random. What is the probability that both what is the probability the bolt came from the first machine, given that it isn't defective? All right. So what I want you to do on the chat, either tell me if you want to use the formula or if you want to use a tree diagram. So just say either formula or tree diagram. And whichever one I got the most vote for, that's the way we'll do it for this problem. All right, guess formula. All right. So first thing we're gonna go ahead and do, we're gonna go ahead and label everything. So we want to find the probability they came from a machine. So we'll say the first machine. So how many boats are manufactured by the first machine?
%75%.
Yeah, 75%. Thank you, Monty. So you put 75%. So what's the probability that a boat was not manufactured by the first machine? So pretty much what percentage of the boats were manufactured by the second machine?
0.25.
Yeah, 0.25. All right, cool. So we have so far the probability the machine, the probability that the boat came from machine number one is 0.75. The probability the machine came from boat number from number two is 0.25. Good. So let's go ahead and look at this 5%. Let's see how should we label that 5%. So it says from the first machine, 5% of the boats are defective, and from the second machine, 8% of the boats are defective. So if you look at this one, they're telling us, oh, I actually need a little bit more space. This one, they're giving us what machine does it come from. So telling us if it came from machine number one, the percentage that defective is 5%. So telling us if I already know the machine came, well, if I already know the bolt came from machine number one, I already know 5% of those bolts are defective. And then it says for the 8%, it says the probability is defective given it came from machine number one is 0.08. All right. Any question on the labeling for 0.05 or 0.08? All right, so lastly, what we're gonna go ahead and do, we're gonna go ahead and see what is the probability that we're looking for. So it said, what is the probability the boat came from the first machine, given that it's defective? So right here, the given is that it's defective. So we're gonna say probability it came from machine number one, given it's defective. So what we're gonna go ahead and do, we're gonna go ahead and just use the formula. So for the formula on top, you want to put probability it came from machine number one. And we're going to multiply that by the probability that is from it's defective given it came from machine number one. All right. Everybody good so far with that top portion? All right. So if you're good with that top portion, just remember that top portion also go on the bottom. All right. So now we're gonna add it to the probability it didn't come from machine number one. So probability it didn't come from machine number one multiplied by the probability is defective given it came from machine number one, from machine number two. All right. Any question in regard to so far the notation? Okay, so I'm gonna go ahead and just start entering value. So for this value right here, you put 0.75. So we put 0.75. For this value right here, that's gonna be 0.05. Then on the bottom, you're gonna put this all over again. You're gonna add it to the probably it's not for machine number 1, so that's 0.05. Oh, sorry, that should be 0.25. And we multiply that by the probability defective given it's not for machine number 1. So that's gonna be 0.08. So now we're gonna go ahead and do, we're gonna go and use class calc in order to calculate this. So on class calc, we'll just do 0.75 multiply by 0.05, and we'll do fraction. Oops, actually, here, let's do this. So let's do the fraction first, and then do 0.75 multiply by 0.05. Then we'll just click right here, so we'll put 0.75 multiply by 0.05. And we'll add this to 0.25 multiply by 0.08. And if you look at that, you get 0.6522 or 65.22%. And that's the answer for that second problem. Any question in regard to how we got the probability for the second problem? All right, so that's it for today's lecture. If you look at it, there's more problem here. So those are just for extra practice. So what I'm gonna do, before I upload these notes, I'll do these problems. And that way you can kind of double check to see if you did it correctly. But that's it for today's lecture. Any question in regard to today's lecture?